Hi, Tool One. I wanted to give you a video to walk you through the lab that I introduced on Tuesday and to help you guys be able to work it and get it done, and also to show you the mechanics of how the tool works. So the first thing we need to do is, of course, open up the Xilinx software. For me, I'm using the 64-bit ISE. What we want to do is then we want to have a new project once it comes up. If you had an existing project, it'll come up in what you've been working on. This is part of my 460 stuff. So what I want to do is I want to say close project. Now we're where we are, so I say new project. And let's call this the adder subtractor. And I need to choose a place for it. So I'm here on F. Let me select F and let me say new folder, and I'll call it adder subtractor. So now I have my file name, my project name, and the directory I want. We want it to be an HDL, so I say OK here. I guess I didn't make it. Then I'll say new. Next. Choose the hardware you have. In case I'm using the Nexus 4. So for us, this is strictly a simulated lab, so it really doesn't matter, but keep the same one you've had. And then we say finish. So now we have a blank slate. So the students asked, how do you get going? So we have a project set up. So I'm going to say new source. Then I get a shopping list of what it is I want to add. We want a Verilog module, and let's call this the FullAdder. So we're going to select Verilog module, FullAdder. We'll say next. So we know the ports for this. So one port will be A input, one will be B, one will be carry in. Then for the outputs, we'll say output, we've got the sum, and the other output we have the carry out. So those are our ports. A, B, carry in are inputs. The sum and the carry out are outputs. They're not buses, they're all 1 bit wide. So now we'll say next, and we'll say finish. So now he gives us a template. We're ready to start modeling our FullAdder. So the first thing we want to do, let's say we're going to use procedural blocks. So I want to say register S carry out because I'm going to assign them values. Since I'm using a procedural approach, I'll say always at asterisk. Then I'll say begin. And the carry out is equal to A ANDed with B, or A ANDed with carry in, or B ANDed with carry in. Then our sum was equal to A exclusive or B exclusive or carry in. Now since I have a begin, I need an end. So that is sufficient for us to have our FullAdder. So reviewing, we let the tool generate the template for us. He identified which were inputs, which were outputs. All the identifiers need to be the exact same spelling. So I declare a register because the left-hand side of procedural assignment is a register. And then I make our assignments. So now I'm going to save this. Now let's check out our work here. So now I'm going to say new source. This time I want a Verilog test fixture. This time it's going to be adder, subtractor, underscore tb.v. Always we want it to be added to our project. So now he does the same thing. He gives us a template where there is the registers defined, the wires are the outputs. He instantiates our design. Now one thing I want to add just for us here, I'm going to add an integer I. So now we initialize all of our inputs to 0. We then wait 100. Now down here he wants us to add our stimulus. So what we're going to do, we're going to say for I equals 0, I less than 8, I equals I plus 1. Now I'm going to say pound 20. I want a little time to go by. And then I'm going to say A, comma, B, comma, carry in equals I sub 2 to 0. So the key thing here to notice is that on the left side I use the curly braces because I want to concatenate these three guys together. Each of these is 1 bit wide, so I'm bringing the least significant 3 bits of I in. So we have the initial, begin, and an end. That should do it. So let's save our test bench. Now we want to choose simulation. If I select this, make sure you select the adder switch. If you select the device under test or the unit under test, you won't get the simulation you desire. So I select the adder subtractor. Then I come down and I ask it to simulate my design. Now hopefully I have no syntax errors. Now when I run it, it all ran really fast. So let's zoom in. So we don't need I anymore. So let's delete I. That kind of just messes things up. Let's zoom in around the data that we've got going on. And let's see if we like it. So I'm going to bring the sum down and the carry out down. Tell you what, let's do this. Let's select them. Choose a different color just so they're easy. So let's make it purple. Now let's see if we like our results. So here we're adding 0 plus 0 plus 1. First we add 0 plus 0 to 0, we get 0, 0. We add 0, 0, 1, we get a sum of 1, carry of 0. We add 0 to 1 to 0, still a sum of 1, carry 0. Now we're adding 0 to 1 to 1. So now we get a sum of 0, a carry of 1. And if we go on down to the end, we get 1, 1, 1, giving us a sum of 1 and a carry of 1. So now we know our FullAdder has been created properly. So I like that. So let's go ahead and leave the simulator. We don't need to save the waveform. Now we want to create a new device. We want to create the FullAdder 4. So we're going to instantiate the FullAdder 4 times. So I'm going to copy that. Now let me show you another approach if you want to do it. Actually, let me use this guy. So I'm going to say new. going to be a Verilog module. We're going to call it FullAdder 4. Keep it in the same location. His inputs are going to be the same. So he'll have an input A, but this time it's a bus, so it's going to be from 3 to 0. The next input is B. Again, it's a bus. It'll be from 3 to 0. Then we'll have the input carry in. Then we're going to have an output sum, so we need to make him an output. He's also a bus, so that'll be 3 to 0. And then we'll have an output carry out. That'll be an output 1 bit wide. So that is the template for our next module. So now what we want to do is we're going to instantiate our FullAdder. So we instantiate the FullAdder. We're going to call the first one FA0. Now I'm going to copy this, paste 2, 3, 4. So I've got FullAdder 1, FullAdder 2, FullAdder 3. Now to FullAdder 0, I want to bring A sub 0 and B sub 0. And I want him to drive sum sub 0. And I want his carryout to be carryout sub 0. FullAdder 1 gets A sub 1, B sub 1. His carry in is now carry out sub 0. So oops, carry out 0. And his sum is sum sub 1. His carry out is carry out 1. So let me just do this right away. So his carry out becomes the next guy's carry in. This guy becomes carry out 2. He becomes the next guy's carry in. So we've got 0, we've got 1. Now we want to bring in sub 2, sub 2, sub 2, sub 3, sub 3, sub 3. So let's check this out. So our A gets distributed across the 4 FullAdders. B gets distributed across the 4 FullAdders. Sum gets generated by the 4 FullAdders. Our carry out comes from the most significant. Our carry in goes to the least significant, and we then propagate the carry out to the carry in, carry out to the carry in, carry out to the carry in. So that looks pretty good. So let's go ahead and save our FullAdder 4. Now let's say here new source. Let's generate another test module, and we can call him FullAdder 4 underscore TB. And add it. We want him to be associated with FullAdder 4. And we finish. So now we should get our template. So now, with the 4 values, the test is going to be a little bit more complicated, not too much. So now, let's just do a few. So I'm going to say, and I need to go up and add my I. For I equals 0, I less than, we'll do 16. I equals I plus 1. So let's go up and add the integer I. Now, what do we want? We want to say, let's do pound 20 again. So now we're going to say A, B, comma, carry in. Now I'm going to assign A to get I sub so I'm going to count 16. I'll just make it easy. 3 to 0. I'm going to let B get I sub 3 to 0. So they're getting the same data. And then I'll let the carry in get I sub 0. So what I'm doing, I'm putting, actually it should be, no, it's 4 bits wide. That's what I want. So, and this should go 0 to 15. So that should cover all these guys. So let's save our test bench. Let's now select the FullAdder 4 test bench and let's simulate. So again, let's zoom full. Let's get rid of the I. And let's start here and see what we get. So let's zoom in. And let's, since we're all decimal creatures, let's change the radix to unsigned decimal. And so let's move the sum down and the carry down. So let's see what we're doing. So now we're adding a 1 to a 1 plus the carry in, we get a 3. 2 plus 2 to no carry in is a 4. 3 plus 3 to carry in 7. Let's just jump around. 6 plus 6, no carry in 12. 7 plus 7, carry in 15. So you can see that the addition is working fine. Now, what we wanted to get to was a 16-bit adder. So now let's go ahead and quit the simulator. We don't need to save it. Now we want to come back and we're going to, so before I leave the FullAdder 4 test bench, I'm going to copy that like I did before. Now let's say new source. So now what do we want? We want a FullAdder, let me name it the same, FullAdder16.v. Next. Oh, okay. Oh, I don't want to be in. So I want to choose a Verilog module. That was my mistake. So always make sure you choose the Verilog module. Now we're going to have an input A. He's going to be a bus. He's going to be 16 bits wide. Input B, he's also a bus, 16 bits wide. He'll have an input carry in. Then he's going to have 2 outputs like we've seen before. The first output will be the sum, also 16 bits. Whoops. The sum, also 6. Oh, why is it going up there? Oh, okay, 15. So let me choose Tim as a bus, 16. And then we'll have our carry out 1 bit wide. Now we're going to do the exact same thing we did before. So this time though, we're going to paste our FullAdder. We'll call him FullAdder4 underscore 0. Let's copy him. And we'll paste him. Paste him. Paste him. So now I have our 4. So now we got FullAdder4 1, FullAdder4 2, FullAdder4 3. A gets 3 to 0. So since we're going to do this, I'm going to select that, copy it, B, sum. Now I'm just going to go do these guys. Now this guy's going to be 7 to 4. This guy's going to be 11 to 8. And then he's going to be 15 to 12. So now we've got our buses distributed. The next thing we want our carry-in to come to the least significant. So again, we're going to make this carry out sub 0. He's going to become the carry in to the second stage. This will be carry out sub 2. He'll be the carry in to the third stage. This will be carry out sub 3. He'll be the carry in to the fourth. So now what do we have? We've got an adder that should be able to add 16-bit values. So let's go ahead and save this guy. Now we'll move to this. So we'll select the FullAdder16. We're going to say new source, test fixture. FullAdder16 test bench. Associate with FullAdder16. Finish. Again, we get our template. Again, let's add our integer. So now we're going to come down with the stimulus portion. We'll say for I equals 0, I less than 16. So we're just going to play a game. We'll say less than 32 just for now. I equals I plus 1. Again, we'll say pound 20. Now we want A, B, carry in to get, so I want 16-bit values. Okay, so we're going to cheat a little bit here. So I'm going to say I sub 15 to 0, I sub 15 to 0, I sub 0 for the carry in. So this is just a simple test bench. Say save. Now let's come back and try and simulate our 16-bit adder. Whoops, I selected the wrong one. So I'm in the 4-bit adder right now. So adder 4. So let's quit this guy. Let's make sure the FullAdder16 is selected. Let's simulate him. While it's running, keep in mind this is using the FullAdder16. Oh, my carry out didn't get hooked up. So full view. So let's go back and debug the carry out. So let's look at the FullAdder16. Oh, so that's a mistake. So his X, he should get the carry out of the previous stage. So that's a mistake. So let's save that. Let's simulate it. Let's zoom full. Let's get rid of I. Let's make sum down, carry out down. Let's change the radix to unsigned decimal. And let's zoom in and see how we did over here. So 9 plus 9 plus 1, 19, 10 plus 10 plus 0, 20, 12 plus 12 plus 0, 24, 14 plus 14 plus 0, 28. So I'm going to stop now. This will get you going. This should help you create your FullAdder, your FullAdder 4, and your FullAdder16, as well as the test benches that you need to allow you to verify that you've done your design correctly. If you have any questions, feel free to send me an email. So hopefully by the time we meet again on Tuesday, everybody would have successfully run the FullAdder16. Okay, so see you on Tuesday.